All right. We'll give everyone just a few seconds to come on in, if they are coming in at all, as for that matter. Ooh, look at all that garbage coming through on the microphone. No está bueno. All right, let's get this show on the road. Welcome, Houdini's fans. It's Friday. It's 3 o'clock, which means it is time for Houdini Secrets Live. My name is Chris, and I'm going to be your host for today's episode. And here I am at Faya, inside of Zelda, and there's nobody here. So screw it, I'm taking off my mask, and I am just saying this is almost as good as doing Houdini Secrets Live over in the summer when I was doing it naked, because it was like 100 degrees in my bedroom at the time, and we were doing COVID, and there was nowhere else to go, and so I just had to percolate. So I'm almost naked here, or at least my face is naked. So last week was really cool. What we did was give an introduction into VAT, Vertex Animation Textures. And what we did was covered a quick introduction into soft bodies. And in other words, what we did was we took a character and then we used it as a template and then got a cloth object and wrapped it around it. And that cloth object then we wrote out to a vertex animation texture of where all the points, their normals, were all written out to a texture file, and the colors as well. Don't forget the colors. And that was put into UE4 and then played back in real time. What we did was created something really cool and was super dynamic. And so that was just one aspect of it. Technically, the Vertex Animation Texture Toolkit has four different output modes. And the first mode was the soft body. Today we are going to be handling rigid bodies. And next week we are going to be handling fluids and water surfaces, which is just things like, okay, last week the topology was constant. And this week the topology was constant, although the topology was not homogeneous. Today we're going to bust it up. Next week we're going to deal with inconsistent topology. And it's going to be really cool, and you're going to see why, but you're going to have to tune in next week in order to find out. And if we have any leftover time today, I'm going to give you folks a little bonus, the kind of reminder of what we did last week, and to play a little bit with my character animation interests. All right, without further ado, let's get this show on the road. Okay, if you would please, fire up Houdini into the last project that we dealt with as of late. Okay, let me transfer it over this. Okay, we've got the, oh, I don't want this. I want this over here. Okay, then we can broadcast it and then get it over here into the demonstration. There we go. All right, we are ready to rock and roll. I'm going to change this over into my demonstration build. And I don't need Python right now, so I'm just going to take it easy on that one. And I am only using 2 monitors today, so therefore I don't necessarily have access to my chat channel. If you are any fans and there's something wrong with my broadcast and something needs to be adjusted, please feel free to contact me anytime via Teams and say, hey, dude, something's gone wrong with your broadcast. Fix it. And I will gladly have to make it happen. All right. Oh, yeah, let me bring this up. All right, cool. So I'm going to do is first bring up the project that we started last week. So I'm going to go set project. And I want my PDG learning machine learning intro. No, that's maybe stuff for Houdini Secrets Live in oncoming months here. But what we want is, oh, we already want the job. Hey, we already got the job here. That means we are already inside the right project. That means I set it to it. Okay, so let's deal with what do we want here. We're going to bust things up. So what do I want to bust up? Let's bust up Squidward. Let's see what it is. So I'm going to go ahead and hit Tab, and I'm going to drop in the squab, or otherwise known as, name this as Squidward. All right, we've got Squidward here. I'm just going to go ahead and go to File, Save As, save it to this job, and I'm going to call it Hard VAT. Well, let's call it VAT Hard, because technically that's what we're doing. VAT Hard Bodies. Sounds like an 80s soft porno film. Okay. Let's go ahead and drop into Squidward. Okay, we've got Squidward here. And let's go ahead and translate him up 2 units. Okay, so what we're going to do is we're going to pick Squidward up just so we can drop him. Isn't that nice of us? Ha ha ha. All right, so let's go ahead and break up Squidward into lots of little bitty chunks here. So I'm going to click on the Squidward node here, and then I'm going to scroll, look over here into the modify. Yeah, modify, I think that's what I want. And is that what I want to find, or is it model? No, I want model. And you'll see that there is a node here called shatter. I'm going to go ahead and select the shatter node. That's exactly what I did. It doesn't look like we've done anything to the Squidward model. What did we do? All right, first, what this did was it took it over into the ISO convert, ISO offset node. So what this did was it converted Squidward into a volume. If you look very careful, well, this is like kind of dark here. So let's this is kind of bright here. So let's kind of darken things up a bit here in the viewport. And my background, boom, boom, boom. And here we go, set this at the dark. Okay, then we can see Squidward much better. You see Squidward's been then transformed into a cloud, which is totally cool because Squidward is now a volume. Okay, pay attention to this, folks. I have a hunch that in 2 to 3 years, all workflows are going to look like this. It's going to have to deal with volumes of some sort. But once we transform it into a volume, what we're going to do is put scatter node throughout the entire volume. So we click there, and we see okay, look at that. We've got 10 points in there. Not so good, not so good. I don't like it. That's not enough points. Now, if we were going to do an explosion using the Squiddy rig approach, which totally works fine, but then we'd be able to use about 70 nodes because you can get about 70 joints for one character in here. So let's go ahead and totally abuse that into something else to make sure we're really getting our money's worth from VAT. So let's transform this into, instead of 10 little chunks, let's transform this into 200 chunks. Okay, that is where we are. Look, and then we bring that into our Voronoi offsets, and it doesn't look like anything happened. But really what we've done is we've transformed Squidward into 200 little bitsy chunks. And that is what we're going to do. Just to demonstrate to you that we're going to do something in VAT that you probably could not do using just regular destruction techniques. Okay, so the next thing I'm going to do is then drop down an attribute delete sub. And the reason why is because we don't want some stuff in here. We don't want to convert the fog. What we want to do is get rid of the explode view sub. Oh, exploded view? No, we want that. But okay, what do we want? Output connects, drop in an attribute delete under big hand. I think contains convert to fog. Output connects convert to fog. And Voronoi fractures. Primitive attributes. Okay, so what we're going to get rid of here, the primitive attributes, is just, the shop material name. Is this here? Is this here? Okay, output, connect, convert to fog, and Voronoi fracture. Oh, okay, so we're going to put this in between here and there. Let's do this. Let's shake this like a mad dog. Okay, got it. In between. Put that into here. And now let's see if we can get rid of some attributes. No entries. Anything here? No entries. No entries. All right. So everything seems... Oh, what we want to do is... My bad. I was wrong. We need to put this attribute thing not there. But we need to put it way up here. And I'm going to cut this right here. Silly me. I need to put this right up here. Because this is going to make sure that we break things up appropriately. But now I'm going to get rid of the material. Because we don't want the material information coming across here. Now, just to test this out, let's see how Squidward's going to look once we've broken them apart. So I'm going to go ahead and drag over here. I'm going to drag in something called an explode. Oh, come on. Explode. Deal. I'll put the display on that. All right. Look at that. This is what we've got in here. We've got Squidward, and now we're going to break them up into all these little bitsy pieces. Now, there are different ways of varying this up, and we're not going to go into this now. Contact me if you want to see how to do this. You'll notice that the distribution of the broken chunks looks a little bit uniform, and things look a little bit homogeneous. And that's because I'm kind of sensitive to noise, and the noise here all kind of looks alike. And we could change that up a bit, but that's stuff for another lecture. Contact me if you want to deal with that stuff. But for the demonstration purposes, this is about VAT, not about breaking things up, actually. So we're going to leave that as is for now. All right, we've got Squidward here. Let's go ahead and convert Squidward here to a rigid body. Ooh. Like I said, we're sounding more and more like an 80s soft porno film all the time. All right, I'm going to go ahead and save this because I'm having one of those days. Actually, today's been an awesome day. It's been awesome because I completed the first draft of one of my chapters for my real-time visual effects for Technical Artist book. And hopefully I can get the publisher off my back. Although I am 6 months late to deliver, I'm still working real hard, darn it. And every little piece that I get closer to finish is a major accomplishment. It's cigar time. All right, after Houdini, Secrets Live. All right, we've got to return. I'm going to return to the object level here. Now we're looking at Squidward. Okay, then I'm going to select Squidward here, and then I'm going to go into the Rigid Bodies tab. Okay, I'm going to look over here, Side Effects Labs, Collisions, FEM Cloth. Okay, Rigid Bodies. Click that. That's what I want. And I want an RBD packed object. Glued object, fractured object. Now, what I want here is a fractured object. That's what I want. There you go. Oh, by the way, if somebody asks you, hey, dude, what does RBD mean? You can say, it stands for Rigid Body Dynamics. Just so you know. Okay, I click on Rigid Body. Okay, I want the RBD packed object. Click that. And yes, that transforms my Squidward object into a rigid body. And how do we know? If we go into our AutoAdopt Network, open this, and there we see Squidward being brought in as a rigid body dynamic packed object. It goes into the rigid body solver, and then we apply gravity to it because we don't want Squidward just hanging around. But if we look over to Squidward, then we see, oh, okay, then we got a whole bunch of stuff put onto Squidward, and we got the whole DOP import here. Okay, interesting issue. Now, I realize we haven't really gone into dynamics yet. I think what I'm going to do is give a whole suite of Houdini Secrets Lives, just going on the fundamentals of Houdini dynamics, because there's a lot to cover here. And so we're going to focus on what we could do to bring stuff into game. And we're going to have translations using VAT and other techniques. But I think we're going to have a few series on creating dynamics that goes into games, because that seems to be something that lots of visual effects people want to know about. And it's something that I could probably use a little bit of brushing up on myself. But anyway, what this does is this creates a hard rest body position, and this assembles all of the thing into primitives. Honestly, I don't know what this does. But if you look at this DOP import, this is the node that we're going to be pulling from and then sending off into our AutoAdopt network. This doesn't pull it in. What it does is it exports it. Okay, and so with that said, we now know how this thing works a little bit more. All right, now if I was to hit play, nothing would happen. If I hit play, Squidward would drop like a stone. Yep, kind of like not much going on there other than Squidward conforming to the laws of gravity. Thank you, Newton. Okay, the next thing we want to do is we want to add a ground plane. Why? Because how much fun is a dropping Squidward without having a ground to smash against and fall into little bitsy pieces? So we're going to get that ground plane by going over to the collisions node and then click over here to ground plane. Click on that and voila, we have the get to go. Okay, now this is something that I haven't kind of figured out yet, and maybe if you know it and understand it, you can come ahead and contact me, because honestly, I'd like to know. And to tell you the truth, I've kind of forgotten. So until I figure it out, I'm just going to have to go on and project to the world that I am ignorant about this. Notice here when I hit the play button, oh, Squidward breaks up. How about that? Looks like I'm wrong, folks. Boy, I've been wrong a lot today. Haha. Okay, but anyway, Squidward goes against the rock surface, and then he blasts apart. Well, that's convenient. Look at that, 200 little pieces, and the simulation finishes pretty quick. Oh, around 120. Oh, let this thing slow down. Oh, let's say I go to 150. All right, cool. I'm going to make this 150. Just to say, okay, this is where it goes well. Okay, it's not looking bad. All right, but we're going to mess all of that out, because this is nice, but we're also working on Houdini, and so we could do things a little bit better. So let's go drop it into Squidward, and let's go put in some bomb action. Let's let him suck on a Tylenol bomb. This is what you do to squabs anyway, right? You stick Tylenol squabs down their gullets and then see what happens. All right. In other words, let's drop a sphere into here. Give me a sphere. Okay, there's our sphere. Now this is a primitive sphere. And let me go ahead and put the display flag on there. And I don't need the sphere to be a primitive. I need this to be a polygon. So I'm going to go and I'm going to move my polygon up to where it's a little bit more of a Squidward level. And then I'm going to scale it inside of the x-axis so that, oops, that's a rotation. We want to scale, so move our radius. Oops, that's the wrong radius. We want the Z. There we go. And let's make it all just a wee bit bigger. And let's change our frequency to something really groovy to give us lots of resolution. All right, then we have lots of objects. So what this is this little Tylenol object here. This is going to be our bomb. And we are going to shove this up the proverbial Squidward gullet. Okay, Now we've got that. Now let's go ahead and put some velocity on it. Okay, I'm going to drop a point wrangle on here, and we're going to go and do some vex. Point wrangle me, Batman. All right, point wrangle. I'm going to say v, which stands for vector, at v equals v at n, capital N. Okay, we just wrote some really juicy vex code here, folks. But you're probably going, what did this mean? I don't understand. Very important. Thank you for asking. Okay, what this statement does is says, okay, create a brand new attribute and call it v. Now it's lowercase v. And in Houdini speak, lowercase v corresponds to point velocity or particle velocity, right? Great. But we're going to say, okay, make that velocity equal to the normal, whatever the normal is. Oh, did we even compute a normal? I don't know. Let's see if we even need to. Yes, we need to compute a normal. We don't even have a normal here. Dopey me. Let's go ahead and add a normal. Okay, we've got a normal here, and we want to put that onto the points. How do we know that we have a normal? Well, let's go ahead and take a look at the geometry here, gang. I'm going to go over here to Inspectors, a Geometry Inspector. Aha! Look at here, we've got normals going everywhere. Isn't that nice? Now, what do these normals look like? In case you don't know, normals are the little arrows that stand perpendicular to every single point. So if we go ahead and turn on our normals, there they are. They look like little hairs. What these are perpendicular components sitting on top of every single point right now. They're usually vertices, but in this case, they're points. And the purpose of their job is to be perpendicular to the surface no matter where they go. And that's why they look like little hairs. Now, if we go over here to point wrangle, we look over here, now we have the normal, nx, ny, and z, but now we have vx, vy, vz. And if we compare these values with the normal, we realize, hey, these are the same things. That's right, gang. We just copied this. All this vex code did was copy these normal values over into the velocity values. Nice. All right. So we've got that happens. Now, how do we actually get this over into Squidward? Well, what we're going to do is we're going to do an attribute transfer node. I'm going to lay down an attribute transfer. Attribute transfers are really useful things. I find I'm using them for texture maps is really useful. But in this situation, we're going to be transferring point velocities. Okay, we're going to connect point wrangle to attribute transfer input 2. And then we're going to connect the attribute between the subpack prims and the DOP import. Okay. So we've got that in here. And so now we'll go back, and Squidward's probably looking just fine. Hello. I don't want to see that. I want to see Squidward. Show us Squidward, darn it. Okay. Houdini has been cantankerous with me all day. Not doing what I want it to. Not nice, Houdini. But I'm going to go ahead and save and see if I can somehow shake it up. Yep, there it is. All right, we now see Squidward back in his all former glory. Okay, so we now, our DOP character does have velocity. Oops. That is v, and it now has a w velocity. That's for homogeneous coordinates for you tech artists out there. You're never going to live it down now, are you? But let's get back into this. Okay, so what we can do is move this over into, we have to tell our AutoAdopt Network to take this value and use this velocity value as the initial velocity for our points, which are actually going to blow up Squidward. I'm going to go up here, go into my AutoAdopt Network. Now where it says Squidward or RBD packed object, go down here where it says initial state, and where it says inherit velocity from point velocity, go ahead and click that. what that does is it actually moves the velocity from the normals, and then it uses it as the initial velocity for the particles as they're flying around. So if we go ahead and move this around, and we see a little bit, we notice that Squidward looked a little bit like he was hovering a little bit. And that's because all of the objects have a value of 1, and it's causing it to kind of poof a little bit. But we don't like it. We want more. More. Okay, let's go back to Squidward and let's give him more. Okay, where we can do this is we go to this point wrangle here, and then if we say times, take the normal here, and we multiply by times ch, and we're going to put in quotes here, we're going to call this bomb value. Bomb value. Okay, now this doesn't do anything. Because it says, okay, bomb value, what's bomb value? So it's probably going to put everything to 0. Aha! But what we can do is, since we have now a new channel sitting here in VOPS, we'll press this little plus sign, and voila! What that does is that exposes a new slider that we can now set this value. Now normally it would be like a value of 1. But what if we wanted to go and push this sucker all the way to 5? So 5 times the amount. And let's return back up to the soft level and see how that looks. Okay, so Squidward looks a little bit lofty there. And it looks a little bit uniform. So I still don't like it. Nope, no sir, I don't like it. Let's go ahead and change up these normals so that they are a little bit dicier. So we've pumped it up, but let's go and put a mountain stop between the sphere and the normal. Now the mountain stop turns Kansas into deep Colorado instantaneously. And what we can do to make sure, just grab the height here and just crank it up. And we've gone from Kansas to the Himalayas almost instantly. And actually, I just realized this, but if you do the math, then east of Kansas is what? Illinois? Or is it Missouri? Yeah, I think it's Missouri, yeah. Now, Missouri is right around almost at sea level, maybe a little bit higher, about 200 feet. Now, Colorado and primarily Denver is a mile high. So wait a second, how did suddenly Kansas, which is like bowling ball, I mean, it's like flat as a pancake, how did it suddenly go from Missouri all the way up to Denver and a mile high? Well, if you go and do the math, you look that half of that distance is actually Kansas. So Kansas, even though it's flat as a pancake, is a big giant ramp leading you up into the Rockies. So just let you know that in case you're interested. But lo and behold, we have something very interesting and very juicy here. Now we are into the mountains. And so let's take a look and see what impact that does on our explosion. Ah, I tell you, things just have not been, oh, I've got the display wrong in the wrong place. I need this to display this right here. Okay, can I actually display this right here to see if my efforts are being paid off? Yep. Pretty good. That's pretty juicy. Yeah, we got Squidward busting up into a million chunks now. That's pretty juicy. I like it. That's good. We're doing really good. Save, please. Okay. And you know what time it is, folks? It's time to turn this into some Vertex animation texture action. So I'm going to right-click on here. I'm going to lay down a ROP. I'm going to ROP Network. And I'm going to call this Squidward out. Out. Okay. I'm going to drop into my ROP network. Then I'm going to drop in a VAT node. The Vertex animation textures, drop that in there. Hello. And I'm going to call this Squidward VAT. Squidward. Yeah, okay, that's good enough. 150. All right, last week where we left off, we took... Uh-oh. Is that my phone? Ooh, what do we have here? Amber Alert. Sorry, guys. We got Houdini Secrets Live here. We can't stop for now. All right, we've got a method. And this method here is soft. We want to change that over to rigid because we're going to deal with rigid bodies. Now, it changed things up a little bit, and it changed some of these parameters down here, and I'll explain that in just a wee bit. But let's initialize for the engine, and so let's get our SOP path. Ooh, we forgot to put a SOP path in for our Squidward object. Okay, let's go ahead and remedy that. Go back to Squidward, and I'm going to drop this down here, and I'm going to drop in an output node. And I'm going to put that on here. I'm going to call this Squidward out. Squidward out. Okay. I'm going to save that again, but I'll go up, back into our route network. And now for the SOP path. You'll notice that I'm always going relative for my SOP references. And for any kind of reference, I'm always going relative. That's because when you're creating digital assets, it's best to use any kind of reference locally and relatively to where you currently are at. Because that kind of keeps everything contained and it prevents any kind of data from going outside of your immediate control. Just a good habit to have. So I'm going to double click here, go dot dot, go up a level, slash dot dot, go up another level, dot, okay. Now let's choose the Squidward object. And now I want Squidward out, which is right up front. Thank you very much. Okay. Now let's take a look at what this says. Pack P scale, particle scale into position alpha. Yeah, I guess that's okay. I don't think that really is going to matter. Normalized data range from 0 to 1 space. Yeah, we want that. Pad power of 2, double textures. Nah, we don't want that. Not necessary. Target texture 1024. Yeah, that works about right. Okay, so where you want the project, we have an export, and we're going to call this VAT Hard bodies. Well, let's call it VAT. What do we call it? Yeah, VAT Hard for hard bodies. All right, and now for the component, I'm just going to call it VAT Hard. All right, I want to make sure we've got all these selected. We want the position and the rotation. Technically, data-wise, believe it or not, the rigid body export is a simpler graph to handle than the soft bodies. Why? Because we don't have to deal with the point normals. Why? It's because all we need to focus on is the particle value position and its rotation. So that is all we're going to be dealing with is its position and its rotation. Okay, I think that's all we need. I'm going to go ahead and save all this. And then let's go ahead and execute this and hit render. Okay, Squidward's calculating. Ooh, and it's taking its time. Ooh, that didn't take too long at all. All right, so we are out. I want to just double check to make sure that everything is kosher. And let's see if it's here. Okay, I think I put this project over on my D drive. And this is TechArt EDU, Houdini Secrets, and HSL VAT. Go to export, and here is a VAT Hard. Okay, then everything was just written out just a few moments ago, and we should have material, and we should have 2 textures. Yep, that's what we got. And we should have a single mesh. All right, we are rocking and rolling, gang. We are ready to boogie woogie. So we've got our output stuff. Let's get off to UE4. Hey, does it look like similar to something? All right, I'm going to go to Content, VAT, And so I'm going to look up, create a new folder here, and I'm going to call this VAT Hard. All right, double click into that. So let's go ahead and import our object. So click on here. Now let's see, this is on the D drive. And we got TechREDU, Houdini Secrets, HSL VAT, Export, and VAT Hard. And here's our mesh. Click onto this. No, I want this. Okay. All right, I want to make sure that everything kind of remains constant, but what we need to do is remove degenerates. Make sure that that is turned off. I think that's about the only thing. Oh yeah, there's one thing we want to do is that where it says Vertex color option, replace. Because remember what we did was we told it put the normals inside of the alpha channel of the vertex color, right? So instead of ignoring it, we're going to use whatever value is replaced. Maybe Luis is actually using the normal value inside of the alpha, since it's, but alpha is just one channel, so I'm not really too sure about that, but let's just see what happens. Okay, everything else is default here, so let's go ahead and import everything. All right, I'm going to double click, and we have a Squidward. Okay. Squidward's looking fine. Squidward's looking sexy. All right, that's all we need to confirm. All right, now let's go ahead and import those textures. Right-click here, import. I'm going to go up a level into my textures folder, and now I'm going to choose both of my EXRs, the one for the position and one for the rotation. All right, now remember the process that we went through last week in order to turn on the the filter mode, that we had to change it over into a vector. And well, we're going to have to do the same thing again because we still are dealing with vectors and we're not dealing with colors. So I'm going to come over here where it says texture power of 2. What? That's not right. But here we are, compression settings. HDR, no, we want vector displacement map, RGB 8. And for the roll down over here, filter, change that to nearest. All right, save. There is our position. And click over here. Compression settings, change this over into displacement map. And our filter needs to go to nearest. Hit save. And then we are doing fine. Very good. Now we are ready to boogie woogie. And just like last week, the first thing we're going to have to do is create a material function. I'm going to right click on here and create ourselves a material function. So where it says materials, textures, look for material function. Ah, there it is, material function. And we're going to call this VAT Hard _ MF. Okay, let's go and drop in and take a look. I'm going to dock this up here. All right, I'm going to get rid of that output result. Don't need them, don't want them, don't like them. Now let's go ahead and expose our library. Whoa, yeah, we know what we're doing. Give us a break. All right, expose the library, turn that off. Yes, turn it on. And then for it says the library, we're going to have to put this, and we'll put this into VAT Hard. And that is what we want to go by. Okay, VAT Hard. Now, I'm just going to leave that as is. I'm just going to hit save just so I have a reference for it. But you know what we're going to do. We're going to apply some of that good old Houdini magic. I'm going to pop back to Houdini. And we're going to change the user interface to normal. And then scroll down here to where it says sample shader code. And then we're going to copy rigid material function. Click. All right. Now we have a copy of our material function in the buffer. You're going, hey, what are you talking about? We're not in UV4. How can we have a copy of the material function? Trust me, it's there. So let's open up UV4, and then I'm just going to click on here and hit Control V to paste. Boom. There it is. Okay, in case you missed the explanation last week, and let me, as Inigo Montoya he says, this is very good, but let me explain. Okay, what you're looking at here is a graph network. And a graph network is nothing but the embodiment of a language. And you say, wait, Blueprints is a language? I say, yep, it's a scripting language. And so therefore, what we did was we copied from Houdini, we copied the actual scripting language. And then we pasted the scripting language inside of the material function window. When we did that, it translated the actual script into actual nodes. And so wasn't that nice? It moved all that for us, and so we don't have to create this abomination of a material function ourselves. Save, and let's move on. Okay, now what we have to do is let's create a new material. And so material, and I'm going to call this VAT Hard underscore M. But guess what? Material. All right. Now, before we go and do anything, let's go ahead and adjust some of the contents for this stuff. So what we're going to do here is make sure this, we're going to look over for the UVs. Okay, how many custom UVs? We're going to want 3. And I just know that there's 3 is because there's 2 texture maps we brought in. One for the position, one for the orientation. And so that means that there are 2. And then in order to get the number 2 to go in any kind of counting computer, we have to count to 3. So 0, 1, 2, 3, right? Okay, so we've got that. And so we want our tangent space normals. Tangent space, no. Wait, we want this to be 3. And we want to look for tangent space normals. And we want that to be false. Because otherwise, this whole spiel isn't going to work if that is true. Now, we've got that here. Let's go ahead and drop in our material function. And we call this VAT Hard material function. Very good. Okay, let's click up the normal. Let's poke up the world position offset. And custom 1 goes up to here, and custom 2 goes into here. All right. Now we have to go and provide a speed attribute. Now, Houdini is not going to give that to us, well, at least not directly. So what we're going to do is create that, and we're going to do that by creating a scalar parameter. Scalar parameter. Oops, is it scalar? Ah, it is scalar. Okay, scalar parameter, we're going to call it speed. And we're going to hook that up to right there. Now, I'm just going to save this because, yes, continue. I'm going to move this over here. And then I'm going to grab my 2 textures and drag those buggers into here. Thank you. Now let's look this up. Which one am I looking at here? This is the position. So I'm going to convert this over to a texture object and then connect it into my position. And so this one must be rotation. So I'm going to convert this over to a texture object and then drag this over into rotation. And we get rid of our error and life is good. Oh, except for one thing. Squidward here is naked. How do I know he's naked? Well, he's got no base color. He's got no metallic. He's got no specular. He's got no rough. Okay, so Squidward here is naked. Let's make Squidward look like a Christmas tree ornament. Why not? So let's go and put him a base color. So let me get a constant vector. Oh, that's just a regular constant. So if we want him to be metallic, so yes, we want him to be metallic, but that means we have to change that to a value of 1. Okay. So let's go ahead and try this again. Vector. I want a constant vector. Constant 3 vector. Constant 4 vector? Yeah. I don't like the looks of this. Yeah, constant 4 vector. Why not? All right, let's give him, make him look kind of like, okay, what's a good Christmas color? I mean, Christmas is over, dead and gone. But what's a good, well, I'm not getting any kind of red here. There you go, there's some orange business. Okay, so orange, yeah, okay, so we're gonna have a magenta Christmas here. All right, I'm gonna click OK there. Oh yeah, alpha, put that to 1. I don't want my character to be transparent. Hook that up to the base color. Now for the specular, it's not going to have any input because it's all specular, it's metal. But do I want this to be rough? Nay. So I'm going to throw in a constant. And so it is not rough at all. So it is looking like, ooh, shiny. Save. All right, so this is good. So let's go back up here. So we've got our material function. We've got our material. So let's go ahead and create a new instance from it. So I'm going to right-click on my material. Say create material instance, and that converts it to a material instance. We'll call this VAT Hard, and we'll call this MI for material instance. Ooh, you're catching on. You're getting good. All right, so for the physical material, well, let's give him a preview mesh, and so let's go for Squidward. And so I forgot what this is called. It's called VAT Hard. Is there a VAT Hard mesh? Yes, there is. There is Squidward looking like a Christmas tree ornament. Okay, we are good to go. Now what we're going to do about all these parameters, well, let's go ahead and expose these. What we're going to need is the speed. We're going to need the number of frames. We're going to need the position min, the position max. We're going to need the pivot min, the pivot max. Why do we need, okay, you can already guess why we need the position, because the position of the particle is going to be carried through in everyone's vehicle. And so therefore we need a minimum value and a maximum value so that we can get the values which are been normalized between 0 and 1. But we're going to have to do the same thing for the pivot. And it's going to be normalized, it's been normalized between 0 and 1, but we have to expand it now between negative 360 and 360, or negative 2 pi and pi, negative 2 pi to 2 pi, haha. So that's where it is. And we're going to get those values from Houdini, of course. I'm going to click over into Houdini and scroll up here and get us some values. Okay, we're on a frame range of 149, and this is our speed. Oh, screw that. I'm going to just copy this. And so I'm going to click paste for the speed. Number of frames, 149. Okay, the position min and the position max. We're going to get those from Houdini as well. Okay, for the position min, here is the position min. Paste it into there. All right. Position max is in here. All right. Okay, things are looking funky fresh. Now we need the pivot min and the pivot max. Pivot min is right here. Control V for the pivot min and the pivot max here. And let's go all the way up to here. Boom. Okay. Aha! there you can see, it depends on how we look at it, but it's looking kind of like a blown up Squidward. I think we're going in the right direction there, camper. Hit save. All right, so let's back up out here, and let's go and create ourselves a whole brand new level. Uh-oh, I'm not going to be able to do that, so I'm just going to create here, level. Can't you give me a new level? So there's my new level. I'm going to call this a VAT Hard level. VAT Hard. Oh, no, VAT Hard. Good enough. Double click, drop into that. Yes, save everything, please. Oh, this gave me that. That's not what I wanted. This is not cool. I'm going to delete this. I'm too lazy, unable to delete. Yeah, I kind of guessed that. Bop onto here. Bop onto the third person perspective, my maps. And here's my example. Let's go and try this again in another window really quick. New level, default, haha. Bet you thought I was disgusted there. Okay, save current. Now let's save this to VAT Hard and save over that. Yes, do you want to replace it? Yes, I do. All right, VAT Hard. Let's go ahead and drop in our Squidward mesh. There he is. And, is this right? Oh yeah, drop him to the surface. And now let's apply for the material. Okay, we've got two things for the materials. We want the VAT mesh, so we got element 1 is what we want. So let's go ahead and grab the material instance, drop this into here. And that's too high, so let's drop this down a little bit. Okay, there we go. Cool, man. Okay. Did anybody watch The Boys? You know when Huey blows up the invisible dude? You know, because they gave him the exploding enema? You know, I think this is kind of like what happened there, but in kind of slow motion here. But instead of the invisible dude, we're seeing Squidward shatter around like biscuits. All right. So there we have it, folks. There's how we do the rigid body stuff and using VAT to do this. Now, this is really super powerful because, man, you could blow up stuff here. What we're doing here is a demolition here that is beyond the capacity that the breakup can actually control inside of UE4. UE4's got a break up, a little Voronoi fracture thing, but it doesn't have this control. And what's cool is in Houdini, you can actually go in and control the distribution of points within the scatter stop so you can fine tune where you want the extra focus to go onto. And so this is art controllable, gang, and this is like infinite control. And we could probably generate, well, how many pieces can we get here? You know, I haven't pushed it. But my guess is that I used to say around 600, but I think we can get about 2,000 pieces, actually. So you can't get 2,000 pieces to destroy anywhere in game. We ought to give that a try sometime to see if we can actually break this up into 2,000 pieces. Maybe we can give a little presentation of that next week. I want to try it first in hand before I do this live. Okay. Now, I did promise you I wanted to do something a little bit funky, a little bit fresh, and a little bit of a surprise, and we do have some time. So what I'm going to do is indulge in a little bit of my favorite stuff. I love character animation. I love story. And everything I do here in CGI is all about creating stories which empower you to help you create your own reality. But in doing so, I need to learn how to create a reality. So what I like to do is let's go and see if we could get a really complicated character that is doing some really fantastic, complicated stuff and have it be for free. Wait, how can you say if I want a complicated character, how can I bring that complicated character into a real-time engine and have it perform for free? I'm going to show you folks. Now, this is something that they couldn't even figure out over at Madden. Please do not tell Juan Chavez. I said that. All right. I'm going to go over here. Let's open up a browser. Woo-hoo. There's my broadcast. And I'm going to go over to Mixamo. Okay, I'm going to log in. Yeah, go ahead, log in. Yes, yes, yes. Okay, we've got all that good stuff. And he's already loaded up here. Okay, good news. I am so excited. Okay, I've got my character Slugo here. Slugo here, he's just hanging out. You know, he's doing the T-pose thing. But let's give him some run. So I'm going to look for a running animation. And turns out the Mixamo library has... Okay, can somebody please tell me what's up with this running business? Now, this is the anime run. What is up with this? Have you... I mean, you know, I like to say that I'm a pretty athletic guy in that I know kind of like physical body and biodynamics pretty well. I understand body dynamics. This makes no sense at all. Because overall... unless this woman has really enormous mammary glands, her butt is still going to be, her center of gravity is still going to be over to there, and it's still going to be like over the rear of her feet. She's not running balanced. She can't run fast like this. In fact, her center of gravity needs to be forward in order for that. So she must have like, you're going to call her Quadzilla because her quads are so big that she's getting driven forward. I don't understand how anyone can actually run fast like this. Makes no sense to me. I guess I was just born too late in the game. But let's see. Do we have something good here? Okay, there we go. Running arc. Yes. Boom, boom, boom. Ah. Okay. I see this. Drunken running. Now, this is something we can appreciate. So I'm going to say run drunk. Dribble. Nut. See, I never learned how to type, folks. So I'm not a touch typer. I have to look at what you're going to say. I'm going to go drunk. Or drunk. No. Male drunk. Drunk run forward. Drunk run backward. Okay. Let's go. Okay, that's what I want. Look at this. Slugo is just running forward. Okay, he's not looking drunk. Actually, what he's looking like, it looks like he's running in a marathon, and he is sitting on mile 25, and he's ready for the home stretch. If you look at the end of any marathon, and you just sit there and watch the people coming in, you're going to see this run cycle. You're going to see this run cycle multiplied by 20,000. That is exactly what you're going to see. So we're going to download this. Say, okay, give us Slugo here. All right, I'm going to make sure that the format is FBX, or I want it with the scan. I want this converted to 60 frames per second. And, oh, there's one thing I forgot to do. Nick, cancel. I want to make sure that this is in place. Okay, the reason why it's in place is because I told you I'm into world building, and I like to create things. And one of the things I'm into is creating crowds of people. And if I want to bring this and put it into maybe Niagara and have the particles drive Slugo here, I want to have an army of Slugos doing their thing and walking around, and I want it to be for free, damn it. Okay, so I'm going to put this in place. So I'm clicking download. So the FBX with the scan, frames per second, 60, keyframe reduction, nada. Okay, download. Okay, boom, 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 boom. Boy, this is taking a good long time. Downloading the asset. Good lordy lord. Okay, there it goes. All right, now I'll come over here. There's my downloads. There's my drunken forward FBX. I'm going to go and copy this. And then I'm going to go over to my project and paste him into my character section. Houdini secrets, HSL VAT, characters, and there we go. Drunk run forward. Okay, there we go. Got it. All right, great. We are good to go. So let's go back to Houdini. And this is not Houdini. This is Houdini. All right. I'm going to go up a level. Okay, I'm going to save this off. And then I'm going to create a new folder. And I'm going to make sure and save it as, am I in the right? Okay, I'm going to call this Slugo Run. All right, so what we're going to do is we're going to bring in Slugo. And this is going to be so stinking easy, you're going to go, man, that's just too easy. He's cheating. Check this out. I'm going to drop in a geometry node. No, I don't. Okay, I've got Slugo. Okay, I've got Slugo here. Now I'm going to use one of the new KinEffects nodes here called, what do we got here? Oh yeah. We want a character import. FBX character import. Sweet. That's just what we want. And so I'm going to choose the file that I just downloaded. So I'm going to go to characters, arrow, drunk run forward, FBX, accept. All right. And there is Slugo. I want to make sure I know who this is. I'm going to call him Slugo. Okay, I've got Slugo here. And now I want to animate him. Okay, there's a real quick way KinEffects has put this in that animates just stinking quick. And that was just drop in a bone deform saw. And if I hit play, woo, that's fast. There he is. But remember, I did it in place, and it's only one cycle, so I got to figure out what the frame range is, and I think it's about 55. Okay, so it's 55. It goes to 56 in a row, so it must be 55. So let's see if this actually loops. Okay, click here. All right, there he is. He's doing the mile 25 run. You go, Slugo, go. All right, I'm going to go ahead and save this because we're just about done here, folks. Check this out. All we're going to do here is we're going to drop in a AutoAdopt Network. This is just too easy. I'm going to call it Slugo out. Okay, I'm going to drop in a VAT node. All right, I'm going to call this VAT Slugo. In fact, let's call it VAT Slugo Run because that's what he's doing here. I think I can change this around. I'm going to have to create some other states in here, but I'm trying to figure out, I'm learning Houdini crowds also right now in order to give me a little bit more sophisticated control. So we've got our start, end, 55, render with take. Okay, soft, yes, we want this to be a constant topology. So we're using the same techniques that we employed last week in order to get our soft topology. Unreal Engine 4, initialize for engine, yes, the soft path. We want to come up here, up. One level, two levels, and we want Slugo. And then, oh yeah, we didn't put it, but it's just the bone deform. That's all we want. Uh-oh, it's thinking. I think it's doing its thing. All right. Very good. Okay, normalize the data range from 0 to 1 space. Yes. I don't even know why I put that parameter. Why wouldn't you go to the 0 1 space? I don't know. But when it says pack normals into point position alpha. No, we don't want that. We want the normals to get outputted to a different texture map. So I'm going to click on this, and that's going to expose over here. Okay, target number size. Okay, let's take a look at Slugo. How many points are we actually going to be exporting to VAT here? I'm going to click over here. Oh, let's take over a look at Slugo here. Aha, rest geometry. 16,000 points. 16,000 points. Will VAT be able to handle it, gang? 16,000 points. I don't know. Let's give it a shot. That sounds like a hefty character. You know, at FI here, we teach our students that your character should be between about 19 to about 25,000 tries. Well, he's pushing that right now. But in doing so, let's make sure that the width is a little bit more robust here. So instead of sending this out to a 1024, let's make sure it's a 2048 texture. Give it a little bit of extra size and speed. So we here, export, we're going to call this VAT Slugo Run. And for the component, we want VAT Slugo Run. Okay, we've got VAT Slugo Run. We want its position, we want its normal, and do we want its color? Well, yeah, no. It's available to us, but honestly, I don't want its color because the color here isn't embedded into the vertices. The vertex colors don't have any color into it. What we're looking at is the texture map values. So no, we don't want any color. And why create the extra thing? Why create the extra texture if we're not going to use it? So I'm going to click on File, Save. All right, we are good to go. Let's go ahead and render this off. Render me out, Batman. God, that was fast. What the hell? Is it done? It can't be done already. Okay, go to Export. VAT Slugo Run. Well, meshes. How big is our mesh? Okay, 5 megs. That's about right. It's pretty big. Textures. We've got the position, and then we've got the normal. Okay. I think that's just about it. Well, golly. All right, let's go into UE4. And so here's exploding Squidward. Let's go ahead and let's go into our VAT. And let's go into our soft VAT, because technically this is where this is, soft VAT. All right, now I don't have to create a new material for this, because the last week the material we already created for it. So we don't need to create a new material function. We don't need to create a new material. It should be already ready to rock and roll. Except this new material is looking for a color, and it's going to error out. Oh, I knew I would mess something up. All right, let's go back to the Houdini. Let's turn on the color. Let's re-export. It doesn't take long. Come on. Okay, it is done. So let's create a new material instance. Instead of soft VAT M, let's create a new material instance and call this VAT Slugo .mi, because it's a material function. Okay, let's open up this guy. And let's see if this is all working. With our preview mesh, let's go ahead and look for Slugo. Oh, we forgot to import him. Look at that. Hasty. We're not ready for this yet because we haven't loaded him in yet. Okay, let's go back into the soft VAT. So let's go ahead and load in Slugo and all his data. VAT Hard texture. Okay, export. And so where's my VAT Slugo Run? Okay, so let's get the mesh in. Here's my VAT Slugo Run. And remove degenerates is false. Okay. All right, so everything is cool. And for the vertex color, we said replace. We want ignore here. So where's the vertex color? Oh yeah, so let's leave this in ignore. I think that's right. And if it's not, if things start screwing up, we know where to look. Import all. Okay, does that look okay? Yeah, there's Slugo. He's not doing much, but he's looking good. Save. Okay, let's get in Slugo's textures. All right, level. No, we want import. Let's go to export, Slugo run. There's our textures. And yeah, let's bring in all three. Okay, I'm not going to worry about the color because this isn't going to be used. So I'm just going to leave that as, but I guess I kind of have to save it. Control S that. So here is my normals. And now this is looking kind of wild. And here's our filter. Change that to nearest. Okay, there's all of our information. Yeah, look at this. It's a 2048 by 432 texture. So we got a lot of information in here. Okay. Well, let's go to the positions. Change that to vector displacement. Change the filter to nearest. Hit save. All right. Now we have everything. Well, let's go over to Slugo. Oh. Okay, lastima. Here it is. I thought I was clever. I'm not so clever, gang. We're going to have to create a new material function. Ugh. Caramba. Okay, not to worry. I'm just going to go ahead and delete this. Do we want to? No, we want to keep that. All right, what we are going to do, and I thought I was so clever, where it says soft VAT, I'm just going to create a duplicate. And it says soft VAT, I'm going to call it VAT Slugo run underscore MI. Okay, yeah, I have to work on that. I have to figure out a better way of translating the textures around. But see, the problem is I need 3 textures here, and they got to be texture objects. They can't be texture. They can't be right from there. They got to be texture objects. So I got to figure a way around that. I'm going to delete those and come over here, and then I'm going to grab the 3 textures. Okay, so this is the position. Convert to a texture object. Move that up here. This is obviously the normal. Convert to a texture. Is this really that? This is the color. Hello. This is the color information, so we're going to drop that into here. So is this my normal? Uh-oh. Now I'm confused. We've got 3 duplicates of the same texture. This is the position. Texture object. This is the color. And this is the color. I have an extra copy of the color. I don't know what happened there. I'm just like, I'm going crazy here. I want to give me a copy of the normals, darn it. Okay, now we are at the normals. Convert to texture object and plug that into the normals. Okay, now we are boogie woogieing and ready to go. So hit save. Now we're going to go ahead and create a material function, a material instance based on our material instance. We don't need that. Let's go ahead and delete it. Sorry. Don't need you. Don't want them. Don't like them. So where is my VAT Slugo run M? Soft VAT M, soft VAT M. Oh wait, VAT Slugo run MI. Is that a material instance? Oh, did I just delete? It's getting late in the day. Oh, there it is. I named it incorrectly. Here's my material. This is fine. I just named this thing incorrectly. Okay. Let's change it to the right name. Rename. Now this might cause problems. Renaming in UE4 is always a dangerous sport. Okay, nothing's been linked to it, so hopefully that worked well. So let's right-click onto here and say Create Material Instance. And now, let's change this over into MI. There we go. Now, let's expose this. So first, let's put the Slugo object. Is it going to work here? So give me some Slugo. Okay. Woo, look at that. Looks like he just auditioned for Joseph and the Amazing Technicolor Coat. Interesting. Let's come back to that. Our VAT soft speed. Our number of frames. Position min, position max. That's all we need. So let's get this stuff from Houdini. Okay, we've got, this is our speed. And then frame range 54. Here's my speed. Come on. Aye, come on. Be good to me. All right, now let's get our position min and our position max. Position min. And let's get our position max. There we go, kind of like negative 100, 100. Kind of like not too bad, just pretty contained. Okay, look at that, folks. We've got a dancing Slugo here. Go ahead and save this. Please save. All right, let's go and toss Slugo down here. And where's my material instance? There we go. And so that Slugo run, material instance, drop them in here. Okay. Here's the dilemma, folks. Look at that. He's looking great, and he's animating awesome. Look at this. A 16,000 point character animated like nothing. Hold on. Let me just check how complex this is. Let me go into Lit, Optimize View Mode, Shader Complexity. Look at that. Slugo is a 16,000 polygon character, and he's almost got no cost on the CPU and the GPU. That is awesome. We could duplicate this guy all day long. Interesting. Okay, let's double check to make sure that Slugo is 16,000 polys. Triangles. God, whoa! It says here that Slugo here is actually 32,000 polys. Interesting. Food for thought. I did not realize it. See, this is what happens when you play. All right, speaking of playing, we're not here yet. Okay, we need the textures. If we go back to Houdini, go back to Slugo, and we look at, okay, if we go look at our character, FBX character import, we import him, and then here's our FBX file, but we got no information on like where his stuff is. And look at I. Okay, the rest geometry, the capture pose, and the animated pose. Okay, something's funky. There's nothing about texture in here. So where's this texture information coming from? I do not know. So let's open up the FBX character import thing and snoop around. If I double click into here, aha, look at this. there's information in here, and look at this. There is information about a material network. Okay, let's double click and go into that. And there is a principled shader. Okay, we click on opacity, textures. Okay, not too much information. We're kind of stuck here at a bottleneck here, gang. If we go over here to base code, not a whole lot of information to go over. Textures, it's not even selected. So where's this texture information coming from? Okay, now I explained this at Houdini Secrets Live a couple weekends ago, but this FBX character import, it's really 3 different characters, and we can see this. Here's the first character. This is the skinned character. This is the rest pose, and this is the animation. It's 3 different objects in here. So if we go ahead and go over to the geometry spreadsheet and look at our thing, we look at here, and here is, we want to make sure to go into the rest. We don't want the rest geometry. Oh yeah, we got the capture pose. Yeah, rest geometry is fine. So over here are our vertices, or our points, and let's see if we have any kind of information about here. No information here about the points. Okay, let's go to the vertices. Okay, no information here about the vertices. All we've got is our UV information. Ah, look at this. The primitives. The actual polygons themselves have information on them. And look at this. Shot material tells us what it's using for. And look at this. Okay. Material override. Interesting. The material override says, okay, it's still using the same principled shader, but it's using this to override the parameters. Interesting. So if we expand this out just a wee bit more, oh, look at, ooh, base color texture. Let's scroll this out. Ooh, look at this. Okay, it's not gonna, it doesn't allow me to go anymore. Does it? There it is. Okay, oh, look at the, okay, this doesn't tell us, it tells us that there's another folder in here. So something happened along the way, and another folder got created. So I'm going to come up here. Come on. Okay, go up here to my characters, and we go arrow, jump forward FBM. Okay, here's an extra folder that's created, and lo and behold, we have textures. Yeehaw! All right. So we have textures to ready to rock and roll and ready to go. And so forth. We've got the specular, the glossiness, which is in other words, I think, for the softness or the roughness. And you got the normal and the specular. Hey, man, we've got just about what we can need. So I'm going to go ahead and copy all these. Okay, got it. And I'm going to go over to UE4, and then I'm going to paste them into my folder for Alt-C. Okay. Is it doing it? Uh-oh. We have since this Emmanuel. Huh. No, dude, I'm in the middle of a broadcast. All right. Control V. All right, so is it sitting there? Yeah, they're there. Okay, so let's go back to our material. And you'll notice here, we're getting our color from this color map. Now this is bogus color, like I said before. Let's go ahead and kill this. Gonk. Okay, out of here. Let's go and get the material that we want. And I think it's called, oh yeah, we want a texture parameter? Texture sample, 2D? Yeah. Okay, so there's our texture sample. And actually, let's get a texture sample 2D because I like being able to change stuff. So let's go texture parameter 2D. And I'm going to call this base color. All right, and then I'm going to get this. Okay, here we go. And I remember the name is like CH19. Did I even include it here? All right, so let's go to this folder here. CH39. So let's go back here. CH39. Oh, there we go. And we want the diffuse component. All right, I'm going to drop that in my base color. Now, here we're going to leave the metallic just as that. Yeah, because there is no metallic thing on here, but we are going to have specular. So let's grab another. I'm going to duplicate that. And I'm going to make this one my roughness. And so let's get CH39. CH39, and that's our glossiness. And let's see, we also want, we got our color. Oh yeah, we don't need the oh yeah, what else do we got here? I can't remember. What goodies do we have here? Let's see what we got. CH39. We've got a diffuse, a glossiness, and we have the normals and the specular. Okay, let's grab the specular and plug that into. So I don't think this is going to have an effect because I don't think it was originally created to be a PBR texture, but we're going to toss that in here just for giggles and see what happens. I would love to explore. And let's grab the normal map. Ah! Okay, do we want the normal map? Now the normal map is coming from the old normal map. We want the new normal map. And that's already hooked up here. And we want the VAT normal map, the one that's changed into forming. So I'm just going to leave that one as is. So I'm going to click all over on Save. And let's go back. Oh, there is our Slugo character. Okay, looks like we're going to have to play around with those normal values a little bit, but we are on the home front, gang. He's got some weird specular values. I think we're going to have to turn this guy into not metal. So let's go and turn this guy into not metal and maybe get rid of his, so Slugo run material. So let's make him not metal. So constant. Metal 0. No, we don't want no metal. And so for the roughness, oh wait, we've got two things for the roughness. No wonder it's looking funky. We've got the shininess. Let's make one of these for the roughness. Which one's the roughness? They're both roughness. So what the hell? One is specular and one is roughness. Okay, we'll use one of these and we'll call this one. Well, let's call this one specular. And so for the roughness one, let's go and change this one to the smoothness, so CH39. And make this the glossiness. That's better. Okay, something is still not quite right with my my normals here. Let's see if we use the normals from the normals that we got. Yeah, let's see what happens. See if that looks better. And why not? We've got them. Let's give it a try. I'm going to duplicate this. And so I'm just going to call this one normals. We'll set this one. CH39. Normal. We'll call this normal. Then we're going to plug in the normals here. So, why is this suddenly throwing off an error? Oh. Okay, I get it. I accidentally overwrote the old one. Okay. We'll call this one CH39. Glossiness. That's going to stop complaining. Save. Yeah, he's still looking kind of a little bit shiny, a little bit crispy. Not really what I want. Kind of like he's almost got velvet on his skin. Still not what I want. So I'm going to get rid of this altogether. So let's kill the roughness. And I'm going to put the normals back to where they came from, that we computed them from the VAT. Well, let's give this a try. Yeah, okay. There we go. He's a little bit more matte now. It's looking much better. Pretty much like the animated character we got. All right, so good. Here is our Slugo character doing the Slugo thing. All right, we've got a much better position now. But here we got a 32,000 polygon character skanking along almost free. Now this is what I call power. All right, folks, that's about all that I wanted to cover today. I'm going to let you go. But before I let you go, I got to give you my commercial. Hold on. Okay, let's go on to the commercial. Nickel, nickel, dime, it's commercial time. Okay, now you got to see my ugly mug for another time. So I'm going to go ahead and bring this up here. Oh yeah, let's bring this up over here. Marketing, I'm still working it out. You know, like who really has a degree in marketing, especially if they came over from the, oh, look at that. It's not even exposed. So what we got to do here is expose this. Boom, boom, boom. Okay, we've got that going. So I'm going to go ahead and move this up here. Okay, on to our commercial. Let me make sure I've got the right thing displayed. No, I don't. Let's get the commercial gang going here. All right, here we go. Okay, folks, if you dig on what you saw today, check us out on 2/5, which is next Friday, for Houdini Secrets Live, where you can check out what we're going to have is version 3. We're not going to rigid bodies. Okay, so we've got to fire the person who's in the marketing department because they're not doing their job. Yes, intro to VAT 3, but we're not going to be doing rigid bodies. We did rigid bodies today. What we're going to be doing is we're going to be going over fluid surfaces and irregular topologies. That's what we're going to be doing. It's part 3 of our total VAT coverage. All right. Now, if you're interested at all into this Tech Art chutzpah, go check out Tech Art Talk Live at 12:30 next Friday. And that's where we're going to be dealing with our continuing series of Python. We're going to be dealing with Python functions and data. Went a little bit longer than I expected to today's early lecture, but it's all really good stuff. All right, cool. So if you like what you saw today, go ahead and click the subscribe button on the YouTube channel right in the lower right-hand corner here. All right, check us out, subscribe here. Or if you really like dig on YouTube or LinkedIn, check me out, Chris Rhoda, on Facebook and on LinkedIn, or check out TechArt EDU, also on Facebook and LinkedIn. However, if you really want to help me, and I'm imploring all you folks out there, throw a guy a bone here. Throw me a bone here. Yeah, talk about as Mr. Dr. Evil here. All right, go to my website at techartedu.com. And in there, you'll see this little pop-up banner. It'll say Get Access to the Latest button. And if you click here now, it will enable you to drop in your name and your email number, and I'll be able to keep you informed of all the advancements and all the crazy wackiness that's going on here at TechArt.edu. And I'm really excited to get things going because, like I said, the progress is being made continually on real-time visual effects for the technical artists, and procedural gems is just marching along. So we're going to have lots of good stuff for you folks coming out. Stay abreast of where you are, stay abreast of all of our announcements, and be up to date with everything. So cool. Sign up there, throw me a bone, and let's go ahead and have a party because it's cigar time. We got one more chapter finished and out of the way. We are rocking and rolling. Okay, thank you very much for joining me today, folks. I hope you have a great weekend, and I will see you next week for Houdini Secrets Live at 3 o'clock next Friday. Arrivederci. Bum, bum, bum. Yes, I had to turn off the broadcast. Now, where's my turn off button? It's somewhere in here. Oh, it's way down there. Okay. Now, this is the end. I mean it for real.